Awesome, awesome. Okay, cool. Um, Welcome Zongwei and Vatsal for the 15th episode on machine learning for beginners. It's really nice to have Zongwei over here, and I remember Zongwei because we met for the first time in last CVPR meeting. We were attending together, and we had a very nice ride from here, Arizona to California, Long Beach. And that's when I got to know about your research work with Professor Liang and your lab group. And I remember actually reading that paper UNet plus plus during my stay over there overnight at Airbnb with Vatsal, and I was just reading that paper. And down the line, I wanted to work on medical image analysis, so I really got intrigued. And right now, when I see the scholar profile of yours, UNet plus plus has now like maybe more than 300, and I don't know if it might be increasing as we speak. So congratulations to you and your team and Professor Liang for that very nice paper. But I guess we will talk about your UNet plus plus paper in a while in this video. But before we start on, I'll just quickly say a few words about this channel for all those people who are new to this video and this channel for on this video. I create these videos on machine learning for beginners with the aim to help people who are starting off their career in machine learning to understand what really machine learning stands for and what really lies ahead in terms of industry and research. And for the very first time, I have invited Zongwei, who has like maybe on the epitome of what research really looks like, because I guess he would be graduating next year from his PhD, and he has a stellar profile in research. So I'm really intrigued to understand what research looks like. And before we move on, I'll just quickly introduce myself. I'm Jay. I'm a PhD student at Arizona State University, working in biomedical informatics. And I'll let Vatsal also introduce himself for this call.
Yeah, hi, I am Matsal. Uh, I am just graduated with my thesis from Arizona State University in medical image analysis. I worked with Zongwei for 2 years, and it's been a very good journey. So, and I'm even excited about to see the other side of Zongwei. So let's see.
Awesome. And Zongwei, can you tell us a little bit about yourself? Like, can you tell us something about your research interests and who are you currently, what are you currently working on?
Hey, my name is Zongwei Zhou. I'm from China. I'm now a PhD student at ASU. This is my fourth year. I work with Dr. Jimmy Liang. He's also a Chinese. And Vassal, I also work very happily with Vassal. We work out some good publication out. I get my bachelor degree in computer science from Dalian University. And then I joined Dr. Liang's lab. So firstly, I get rejected from the PhD because my TOEFL, English, it's terrible. And the ASU decided, hey, why not you improve your English first? Okay, then, but Dr. Liang is really kind. He recruit me as a visiting scholar for the first year so that the English not so crucial. Then I joined, and from the 2016, then I started working on the deep learning on medical image analysis. And now my thesis topic is pretty settled down. So my main focus is the annotation effective deep learning for medical imaging. So I think it's a pretty exciting topic that I am really fortunate to get a guide to this topic, and I also get some publication surrounding this, focusing on this topic. So that's a brief introduce of myself.
Yeah, that's really great to know. I mean, yeah, I didn't knew like you had a reject from ASU on the first go, but yeah, I mean, now when ASU looks back, it's really a bad decision on their part. But yes, can you tell, like, we all see a lot of applications of AI in a lot of topics right now. Like it can be, it's used in a lot of domains, self-driving car, medical domains, and all those things. And was there a reason you picked out biomedical informatics to be your research focused, or like what really was the thing that really motivated you, and how do you see that domain right now? Like, do you see a great amount of research being done in this domain? Was that the key thing, or maybe something you really liked being benevolent, like, okay, I want to do something in medical domains? What was the key motivating factor for you?
Yeah, it's deep learning is a tool. So how do you use deep learning is mostly based on your interest. If you're interested in natural language or natural language processing, then you can go to NLP. If you are interested in agriculture, then you can apply to the agriculture. If you're interested in astronomy, then you can use deep learning to find the star. So yeah, it's based on different people's interest. So I select medical imaging. It's not initially not my decision. So I started familiar with deep learning since 2015, my last year in undergraduate. So that was my birthday, and I have a really boring last year in college, and I need to find something to work on. Then I just contacted one of the professor in my department, computer science, and he is working on medical image analysis. Then I said, hey, then let's work on the medical image. Then then that's the time I start working on it. But now, as the time goes, I just think, oh, deep learning is a really powerful tool. So it can specifically beneficial for something that human really hate to do it, because something, maybe it's a really boring, tedious, time consuming, like a lot of dirty job. And deep learning at the same time also good at some job like a human cannot do very well, like calculating some pixel-wise analyzed human eyes may not be capable. So so by understanding these two advantages, I think medical image analysis may be a good application for deep learning. One of the great, best application, because radiologists every day so busy, and a lot of small things, detailed things they don't want to do, then you can use deep learning. And something like a radiologist cannot tell, like maybe need a biopsy result, and deep learning, hopefully if deep learning can do it, it's also very good. So that's mostly two reasons I select medical image analysis.
Yeah, I have a question for you. So I recently checked your profile, and even I'm part of this paper. So you recently won the MICCAI Young Scientist Award 2019. So congratulations on that.
You too.
Thank you. And so I have seen your like struggle, like from the first person view, like how much you worked hard and how much effort were done in developing this award-winning method. And so I have a question, like, can you just tell the viewers how you came up with an idea and what it's an idea about and how it aligns with your long-term goal of the thesis?
Yeah, so the paper Vassal was mentioned is named Models Genesis. It's a very cool name, like named from my advisor. So this paper is doing one job, that provide a 3D pre-trained model for the imaging community, for medical imaging specifically. So, so this paper gets good attention. I think it's because people really need it. So let's think about the 2D imaging vision task. So if you want to train a model, and you will naturally just download the model, pre-trained model from ImageNet, because it's pretty powerful, and you can like use transfer learning to translate this knowledge to a lot of different tasks. But now the question is, if you face a 3D problem, like mostly happen in the medical image analysis, because the CT, MRI, ultrasound, most like a dominant modality imaging type is in 3D. So that if you want to use the 2D ImageNet model, it's not so straightforward. I mean, it will have some gap. So we realize this gap. So that's the motivation. We want to do this thing. We want to build a model, so when people ask, oh yeah, I have a 3D imaging task, what do you suggestion? Yeah, my suggestion is to download the model genesis and start from there. It will give you promising result, at least better than learn from scratch. So that's why people like it. It's very straightforward. So I provide a tool that a lot of researchers can use for their own job. So it's like a basic tool for deep learning. And another thing, like people may like it because this framework is a very, very simple framework. It's actually not very new, but it's the first time to use in 3D imaging. So it's a very simple framework that everybody like read the paper, or even not read the paper, read the abstract or the figure even. They can like suddenly understand, oh, just the image restoration task. You mess up the image and restore it, that's it. So that's easy. And another advantage is this method really work. So it's a really magic, like a simple method, but really working. So this makes the not so many gap, like the beginner, even for the machine learning beginner, they can learn. It's not like deep learning, it's like philosophy, engineering thing. It's really like easy to understand. You can really design your own framework based on it. So, and another thing, maybe it's become like people like it, is we make it public available, because nowadays deep learning, if you make it public available, then you just download and you can reproduce other people's work and you can translate to your own work. So public available is very important. And the most important part is the writing. So as I said, my writing is not very good. So at the beginning, my writing is even terrible. So I'm very fortunate to get very good supporting from my seniors student from our lab. It's Nima. He's very helpful in the writing the paper. And actually we just work closely and write multiple like versions to finalize this MICCAI paper. So that being said, the paper submission and the final camera ready version to the public that other people can view, it's a totally different two paper. So one paper is about more technical orientated writing, like this is what we do, this is what parameter. Another, now the version that you can see is more like a high level view, like why this is important and what's the advantage of our technology, what's the property of our technology, and what's the observation from the so many work. So the writing also very important. That's what I figured out to get maybe why the reason people like it.
Okay, so yeah, that was all the good stuff, like once you developed a method. But what I am interested in, like, how was your journey? How much time you spent in just developing one method and like realizing the importance of the question? Like, what do you think? What are the key factors in, like, before you jump into the research problem? What should you look for? And you can use this paper as an example.
Right. So the question is how I started this this idea. Yeah, it's a little bit starting idea. It's always the most difficult part. Like the idea is not always like come to your mind, and it's not. The first problem is you don't really know what's the clinical need. So what's the direction you need to think about? And the second, after you know the clinical problem, like what a physician needed and how to come up with a good solution. So that's these two directions all both are very challenging in my opinion. So the first solution for the question, what's a good problem, usually based on my advisor. So he has more experience. He knows what's the research community now, what's the state of art and what is missing. That's what a PhD do, right? So we figure out what's the problem. And then after he advised me, hey, we need this kind of pre-trained model. Then the job is how to get to the good idea, how to pre-train this model, how to make it happen. Then to be honest, how to make it happen, I don't really have a very clear mind trail. So basically I was eating hamburger, then the idea just come out. So yeah, so
you were eating hamburger with me.
Not with you, you know. So if you want a good idea come to your mind, I usually be alone, you know, and do some relaxing stuff. But the key is don't forget to think about it. If you forget to think about it, nothing will come. If you are eating hamburger, then you think about it, then it may come if you are lucky. So that is basically how it starts. But what kind of research problem I will select like in the future, I usually just will like estimate my capability, like this thing, can I do it? Like, do I have a capability to accomplish it? If I cannot, I will not select this problem. And another fact is I do have the resource to make this happen. Like if I don't have data set to it, then forget about it. If I don't have a GPU, then don't do it. And the third factor I would say is once this problem gets solved, other people should care about it. If other people don't care about it, then of course, some research degree, some research problems, they do some very advanced work. But for myself, I will not do it. So it have to be like people really care about this problem. So before I start, for example, model genesis, I will mostly like do some small, like a baby experiment, like design some tiny concept and do some proof of concept job to really think, okay, this method may be promising. Of course, a lot of good idea come in, but not all idea works. So I need to first spend a little amount of time to prove this idea, at least to some degree it helps. Then I may like devoting most of my time on it.
Yeah, I remember you told me that you should reject 99% of the idea.
Yeah.
And just think about 1% of the idea and devote their methods on it, right?
Yeah,
I think
because
that's a good
if you want
strategy.
make one idea work and push to the end, it's need a lot of time. It's not like this month I work on this idea and come out next month I can change another. So for example, model genesis, from the start to the end, I spent like almost 2 years from the conference, like from the idea comes and to the conference publication and until to the journal publication. So it's a long journey. So you need to really investigate, is it worth to do it? If it's not worth to do it, don't just waste time on it. Yeah.
And there's another thing I want to add is, like, I have seen you personally for 2 years, and it was not like the idea came overnight, right? Like first you had another idea, you worked on it, you tried to publish it, but then you just discarded it. I don't want to take the name of the idea. So,
Right.
but then that idea you used as a pre-processing for the current version, right? So my point is like, sometimes that failure, if you have just stopped there, the first idea, okay, this is not working, right? Then you won't get an award-winning paper. But in fact, that first idea was used as a pre-processing tool for our paper, right? So how do you want to say anything on that? Like when to stop and what motivated you to just keep on going for 1 year continuously in just developing a method, right?
Yeah, so as you said, most idea from my mind is discarded because of a lot of reasons. Most of the reason is the idea itself doesn't work. Another reason is I didn't dig into it. maybe it's a good idea, but I just don't threw it away. Yeah, that's also possible. So the model genesis, the reason I push to the end, it's the first, as I said, the task is easy. Not easy, like I can do it. Like because there's not many competitor, you know. As I said, 2D ImageNet is the dominant. It's a standard. But 3D, hey, if you ask a question, 3D pre-trained model, yeah, maybe you need to think about 5 minutes to get some answer that you don't know. So this is like a new direction. So that at the stage that I think as PhD student, if I can do it, it's very good. So not very competitive. That's why I think, yeah, I should like continue this no matter the idea how good it is in which level. I still need to make it published because maybe people can read my paper and they think about a really good idea. It's possible, right? So I think it's worth to do it. And also my suggested method, model genesis, also it's look very like promising. We did a lot of large scale experiment on it as well. So it's significantly better than learning a 3D model from scratch. So that's why I think this is a good topic that I want to spend like 2 years or even more.
Thank you.
Right. Yeah. Yeah, that's really interesting. I mean, learning about the motivations, and boy, this is very personally helpful to me because I'm just starting off my PhD journey. So this would be kind of a very useful advice for me. But was there like I really understand what real like how Vatsal mentioned, like understanding and never giving up, like it could be the next award winning paper for anyone else. But talking about the technical aspects of research, like for example your paper on UNet++, what really, how do you approach a problem from a technical aspect that that you decided that okay, let's use an ensemble techniques of UNet models or skip connections in general, or making or using ResNet models instead of the already pre-trained models? How do you like, is it totally just the literature survey, or like how do you define like what models to use for that particular application? Is that something, what have you learned over the time, like how to choose models, when to redesign, when to think of a new architecture, or maybe just start something from scratch? What have you learned over that 4 years of your PhD?
Right. For the model architecture, that's actually a very engineering topic. So that you don't really know when you get a new task, you don't really know, hey, which architecture it's the best, always the best, works always best. And yeah, so that so this area is different from model genesis. Model genesis, it's like you ask a question, people not sure what's the answer. And this question is, you ask, oh, which model I can use? People has a lot of answers, you know, the ResNet, DenseNet, ResNet, Next, a bunch of architectures. So that this area is more competitive, like it's risky, like you propose a new architecture, maybe tomorrow it get beat by other architecture. So this is a really competitive area in my opinion. So I developed UNet++ because first, as my logic, I think I can do it because the UNet is a well-established architecture for the image segmentation. It's like ImageNet. It's my rule is if people ask it, the first answer is always the best. Like if you answer what's for image segmentation in medical imaging, UNet, don't tell me other things. Okay, then that's the moment I decide to, okay, put my foundation on the UNet. And then I study the UNet paper. I study the UNet architecture, so understand what each component is doing. And so I think it may be more promising instead of like come up with a brand new architecture, like a really novelty, so stand upon the UNet shoulder, if you want to say. And yeah, so the motivation of UNet++ is deep. In general, the deep neural network is very deep. That's why a lot of deep layers. It's like a lasagna. or tiramisu, you know? And the problem is people don't really know how deep you want to go. Like, yeah, you go deeper, but how deep? So to answer this question, we do some toy example, like I introduced you before. When I start a project, I have a toy example. So the toy example is we want to understand, yeah, so deep 1, deep 2, deep 3, deep 4, which deep is most useful, you know? So we select a data set like a cell segmentation, and we test on it. Like we put 1 layer, 2 layer, 3 layer, 4 layer, and to see what's the performance. And we say, oh, for this data set, 3 layer is the best. And we change a data set. And we found, hey, this data set, 5 layer is the best. And sometimes another data set, 2 layer is good enough, give you better performance. If you deeper, it go worse. Okay, now the conclusion, the observation, there's no conclusion. Observation is, the different layer can help for different application, or can help for different disease detection segmentation. So then we say, why not just utilize every layer's information and let the model itself to decide which layer I want to go. So that's why we develop some nested layer. It's not very complicated. It's just, oh, I consider layer 1. If you think layer 1 is good, just go ahead and use your layer 1. If you think layer 4 is good, go ahead with layer 4. So we throw this difficult problem to the model itself. Let the model to optimize which depth is good. So that's why in your you can see our UNet++ is nested. Look like very complicated, but actually make the model decide itself which one I want to go.
Right. Yeah, this is really cool. I mean, yeah, I can see some of these aspects creeping into my research work. So maybe even offline, I would be keeping in touch with you to have some really good advice of how to moving forward and not making huge pitfalls for me. But yeah, this is really interesting. But deviating a little bit out of the whole deep research work and maybe addressing what I frequently get asked this question a lot, and maybe I also ask this question a lot to myself before choosing for a PhD is how if a person is really a graduate student or maybe even an undergraduate student, how does he or she decide that maybe PhD is right for him or her or not? Like maybe the person is interested in doing research, but is PhD something really necessary for him or her, or choosing an industry job where research could be done? So did you question yourself all of these things? Like how do you like what would you say for whom PhD is really fruitful versus for whom industry would be really fruitful? Like what are your honest reflections of your 4 years of PhD, and how PhD has helped you, and maybe joining an industry would not have been a good option, or would it have been a good option for you to join industry? What are your thoughts on that?
Right. So the question is, what's good about PhD and what's good about the industry? So to be honest, I don't have much experience in the industry. I have some internship, but I haven't really like focused on that place. So when I apply for PhD, I ask myself some questions like, okay, so if my long-term goal is become professor. So this pretty much answer your all question. Like if you want to become professor, go get a PhD. Otherwise, you cannot get a professorship. That's it. Okay, that's the first question I answer. And the second question is, I'm an international student. I'm from China. So if I want to like work in America or even live in America, build some family, then what should I do? Which degree should I go? Go PhD or MS? So I'm not sure if you're familiar with the some policy, like PhD has a more chance to get the green card. So that's another very important fact for the international, because in this area, like AI area, a lot of international students like us. So we need to decide like, oh, master or PhD. So we want, if we want to live, if you want to go back to like China or India, it's fine. So, but I think at least to get a green card, it can give me freedom. Maybe one time I decide to work in China, one time I decide to work in America. So at least I can choose. But if I don't get a PhD, then pretty much I just go back to China. So I don't want to be myself to be restricted to some degree. So I think get a PhD also helpful. So this too is a very like a motivated reason that I choose PhD. And another thing is, I found a PhD compared with working in the company, that company usually you got a boss, right? But a PhD, you got an advisor. So advisor's name is much like a gentle. It's not like a boss. Hey, you do this week. Don't see me if you don't finish it. So PhD is more like educate you to prepare you instead of push you. Like if you don't do it, I fire you. It's not like that. So you can meet some good mentor, or even more than one good mentor in your life. This is very important, I think. So instead of, okay, you just go to the industry and like start working from the 20s or 30s, I think everybody will become an employee in some age. Like most people will have an employee experience, like work for somebody. But it's not very usual, like you spend 5 years, 4 years, or even 10 years with one mentor PI and developer really do some focus on some topic and do something. It's so I just want to experience some different things. So yeah, I will experience employee, but maybe in my 20s, I will like build some good education myself. So that's I think like a PhD give me the advantage. So first two is very solid, and third maybe build a good mental mentee. But on the other side, so if you become a PhD, which means you cannot be really rich in your 20s, because a company usually like have a really good package for you, and you can develop, start to develop your own life, like at earlier than PhD student. So PhD student every year, every month, maybe just renting and renting house and eating. That's all the cost. Then I have no money at the end. So that's one thing, but it's not a big deal for me. So it's okay. And the second is PhD means you need to focus on one thing, like for a long circle. It's not like a product. You just finish your own part, then that's it. You can work on another part. So, but a PhD, you like, for me, I really need to lead one publication to the end. Like, as I said, the one publication circle is pretty long. Like maybe for a conference paper, I may need 1 year. And if I push to the end to the journal, maybe I need 2 years or even more. So this is a pretty like a big commitment for me. So that it's I don't see, maybe nowadays the good company also do this, like they also want to publish good paper and let the employee really become a good researcher. But I think a more straightforward way is if you really want to become a researcher or professor, just jump into the PhD, spend like 5 years and get some good publication. It will also benefit for the job hunting in the end, I think.
Yeah, this is really interesting. And would you have any tips on like what are the obvious pitfalls of any PhD student? I mean, because I'm realizing that the whole the process of PhD has very little incentives to offer, and it's really hard to hold on to PhD and really be excited about it. So would you say any tips on that? Like some kind of advice that, okay, always stay away from this kind of things, or maybe kind of a red flags. Were there any red flags that you discovered that, okay, I shouldn't have done that? Because I was talking to Vatsal a few weeks back, and he explained to me that, correct me if I'm wrong, like maybe the model genesis paper, you submitted it to few conferences or maybe journals. I don't remember the exact details, but it got rejected maybe
Yeah,
two
it was
times or three
UNet
times.
plus plus.
Yeah, sorry, UNet plus plus, or yeah, UNet plus plus, and it got rejected maybe twice or thrice, and only after the third try you realize it got published, and now it has a stellar like score to it. So like any tips on like maybe understanding that, okay, well, like did you have any boundaries that, okay, if maybe I get rejected 4 times, I would not devote enough time to the UNet plus plus project, or maybe I shouldn't be doing this, or I shouldn't be doing that? Because I frequently ask myself a question. I'm a computer science student. Should I be doing a lot of medical imaging projects if I want to make a diverse profile? I don't want my profile to be narrowed down to a medical imaging person. I still want to be able to work in Tesla or something like that, like who works on other computer vision aspects. So how, like these kind of boundaries, do you have any kind of advice on that, that, okay, stay away from doing these kind of projects, or maybe try to like maybe take on 3 projects, not just 1 project during your PhD, or like some kind of safety mechanism that you might have developed for yourself during your PhD? Do you have any tips on that?
Right. So UNet plus plus get rejected 4 times actually. It's mostly my fault. So as I said, English is really terrible that time, like 2 years before. My English writing is pretty naive and wordy, and sometimes grammar. I mean, mostly grammar issue. And yeah, so the review just honestly point out the writing's no good, but the experiment is okay. And yeah, that's a time you need this kind of disappointment so that you can realize how bad you are. And yeah, that time I was thinking, hey, how can I improve my writing in a short span of time? But actually it cannot, because that's the first advice. So don't think the writing skill can be improved like 1 month or 2 months. So what I did is I first work with a more senior student, because when I joined the lab, it's I'm the youngest person at the same time I'm the oldest person, because the senior graduate student graduate at the year I'm in. So that means the only advice feedback can get is my PI. So that really like become a too much gap. You don't want to have too much gap to work with other people. Like what I do my best, and to his eyes, it's like nothing. So you don't want to do that. So what I found is, hey, I may seek help from the previous student, which, yeah, maybe 5 years different from me, and he has he also goes through the PhD. He may give me more advice, and he also very good. He really helped me to improve my writing. He also directly helped me to write a paper and give me feedback, which part is wrong, which part is too wordy, which part I need to elaborate more. So that actually really helps. So that would I say the tip for the newbie for the PhD. Always like contact with your senior student. And for another thing, how many projects you want to work on simultaneously. I would say if you are newbie, like first 2-year PhD, maybe just focus on one project, but make sure you have determination, not determination. You have a belief that this project will do. That even though you believe it's okay, even though your PI don't believe it's okay. So, but you need to focus on one project and make it happen. If you cannot, like a UNet plus plus, I think it's a good technology, but the problem is myself. I cannot write it good. So that's okay. That's not the reason I give up this project, but it's not projects for. So I just figure out how to make this my shortcome like to the average, and then eventually it's get published. So when you want to give up one project, you need to like evaluate yourself, like, is this your fault, or it's a project fault, or it's a idea fault, or it's something. If it's your fault, it's okay, it's not a big deal. You just figure out how to overcome it and improve yourself. If it's the idea fault, that whatever experiment you do, it doesn't work, then just don't work, just forget about it, you know. That's my opinion about the project, when you need to give up, when you need to pursue.
Right. And one more question that I had was, like, you must have joined somewhere into 2015, or maybe, I don't know, 2014 or so, in your PhD program. And if we see the timeline of deep learning, like, maybe it was on the sweet curve over there, that we see that the use of deep learning was getting much more frequent into not just medical domain, but a lot of other domains. And great results were published, great algorithms were coming in, and a lot of papers were getting published. Over the time of your 4 years, and maybe in the niche domain of medical domain that you have been working on, how do you see this biomedical informatics domain really progressing? Like, for me personally, I see a lot of cool applications being done, and deep learning has very promising results. But from a person like you have definitely a longer foot than me into this whole domain than me. So what would you comment on that? Like, what are the open challenges that you personally, I understand you don't know the whole domain, so it's completely fine. Like, use your opinion on this. But what are the, how have you, for the first question is, how have you seen this domain particularly growing, and what are the promising things for any person who really is confused, like, where should I want to apply deep learning, but I need a domain, like, why he or she should choose medical domain? And secondly, what in your opinion, what are the open challenges that maybe the whole research community in medical domain might be currently focusing on? What are your views on that?
Yeah, so deep learning, it's suddenly become famous not recently, 10 years, in the recent 10 years. And it is really promising, I would say. So for the first time I meet deep learning, I use it. It's pretty easy to get started, because a lot of good blogs and GitHub, I can just hands on it. And yeah, I found it's really promising. And now, as long as I'm working on the medical field, I also find that, hey, deep learning is really influence the medical domain as well. So let me just give you one simple example, like COVID-19. Nowadays, COVID-19 is a start from last year, December. It's a very like a sudden thing. Nobody can foresee this. And actually, from this year, January, or even earlier, the hospital in China already like really actively seek help from the industry and academia for the help. Hey, deep learning, it's very promising. Give us some help, because so many patients come in, come out. Not many radiologists really understand this novel disease, or really have time to do every patient carefully. So how to do it? First, they seek the help from industry, because industry usually hold a really promising tool, because academia maybe some ablation study, but industry, they usually just welcome some already well established technology. So they first seek help from the industry. And in a short span of time, the deep learning algorithm based CT scan or other CT scanner or other computer interaction, it's already built into the hospital. And this device can help a radiologist or physician to do the diagnosis when the PCR even not come out yet. So at the very beginning, like a Chinese government, they decide to use a CT scan because it's more straightforward. That time, no PCR. Of course, now have a PCR, then we don't need to go through this trouble. And another thing the AI tool can help is quantify the diseased region, the infected region in the body. Quantify, what I mean quantify means how big it is and how bad it is and how many burden estimate. And even they use this like a histogram to estimate like how many days you can live. Is pretty crucial, but they do this. They estimate the burden, estimate the after the treatment, how good you are gradually be. All this information is a PCR cannot give you, because PCR give you binary decision, but this deep learning or even CT, in the CT scan, we can do this. So apart from the industry, the hospital also like really actively cooperate with the academia, like a university, because usually university a little bit slower than the industry. They need some funding, they need some project settle down. So, but academia in this time, urgent time, also very actively responds to this disease. For example, a lot of people just group some public available data set on the website, and they want people like a collective effort to really focus doing this. And another thing is a lot of well-known journal and the conference, they have their own special issue on the AI to meet COVID-19. It's another a really good thing. And the numberless the seminar, it's happened like us. It's a talk about how far our group is and communicate each progress. So in summary, the industry and the academia all very actively believe like deep learning can do. It's very promising to do this, because if it's not promising in this urgent time, who will care about something like deep learning, you know, if it's not promising? So in my view, so this year, the domain growing is really fast. So if you say 5 years ago, if you ask a doctor or physician or radiologist, hey, what's your opinion about the deep learning? Hey, I'm not sure about this. Then maybe it's not as good as me. And then people try to beat, like really competing, like oh, AI will replace the doctor, or AI will like a doctor's job will disappear or something. And now on, it's gradually people just realize it's just a tool, that doctor also love to use AI as a tool to really like do some dirty job or to do some really difficult job. So now it's the domain grows from the like competing, like I dot you, you dot me, I dot whom, I don't know, and to the really using this and make it really a tool, not like a fantastic like a attacking thing. So now the doctor just use AI. So it's to me, it's a very good achievement to like domain shift from the competing to the real application usage.
Right.
Yeah, I want to add something. So I think in near future, what's your thesis topic is cost-effective medical imaging analysis, right? I think that's the near future for sure. Like we don't want to use so much annotation. We don't want to use so many labeled images, because obtaining labels is very expensive in terms of medical. So that's, I want to hear some opinion about that. And my second question is, in a long term, like what I see right now in the field of just computer vision, I'm not talking about medical imaging in general. I think the field is saturated a little bit. Like last 2 years, there's so much incremental approach, you know, like in NLP, people are talking right now about GPT-3, but they are just increasing the parameters and it's becoming more like a GPU intensive task. So I want to get your view on vision side too. Like, what do you think of the long term? Yeah, short term, I agree with your dissertation, what you did, and that's fantastic. So both short term and long term. Can you tell more about that?
Yeah, so every like a really novel thing is not like happen every year. It's in the history, like Einstein's theory, Newton's theory. It's not like happen like every year, this thing. So usually when these things happen, like deep learning happens, usually have like 10 years, 50 years to have some incremental degree, like from 0 to 1 and from 1 to 11. It's usual. So it's helpful because like a really good idea, deep learning at the very beginning, it's not very powerful, to be honest. Like only can get the digit detection or recognition, and now it can disease detection. It's a really good change. So the like 10 years before, the deep learning cannot do this. So the incremental innovation is important as well. And for the long term, yeah, I really hope that we get a more and better technology come out, like even shallow learning or whatever learning it is. Yeah, I do have some good technology. That's also the fact that I select my research problem. So I try not to like focus on deep learning or SVM or random forest. I try not to focus on this kind of technology-wise problem, like how to improve this problem. I more care about how, okay, you have one tool, how to use it better. For example, you have one technology, which sample you want to learn first. That's like a more general problem. Like if 10 years later, new architecture come, my research problem still people interested in. It's not like, oh, this is 10 years before deep learning, who cares now? So I try to select a problem that is suitable for like a technology in general. For example, another example is my thesis topic, the cost-effective deep learning. So it can be cost-effective other learning. Like so my focus is not to get deep learning better. My focus is how you have, oh, you tell me you have a good idea. Okay, my thesis help you to make your idea more cost effective or more fast to get your perfect accuracy. So that's a research problem that I prefer. So yeah, deep learning may be replaced by other technology in the future, but it's fine. We just see. Hopefully it's get from me the new technology, you know.
All right, thank you. We will be keep in touch with you. Like I will always read your paper. So
Thank you.
But yeah, that's a really interesting perspective. And yeah, before I conclude, I normally ask this question a lot to all the speakers that I have invited, but most of them they don't have a very stellar profile in research. So feel free to edit the answer that you have to this question. Is in general, for any, like this is for the viewers or maybe the students who are watching this video, for any person who is really interested in research but maybe just have started learning about deep learning or machine learning, or in general the whole domain of researching these mathematical models, what would be that one tip that you would give for him or her to understand that, okay, is research, because I see a lot of people, even I had those incidents where I felt like, okay, maybe research is not for me, like this is really boring, I would say, because not a lot of people really enjoy mathematics behind the deep learning architectures. What would you have one tip or one advice for people, any, like they could be undergraduate student, graduate students, or PhD students, for anyone who is actually planning to do research but they just don't find that interest in the very start phase? Because before you answer, like a few words from me would be like, it doesn't give you that gratification factor like a job would do. Like you said previously, job has a lot of incentives. You can make your own life, but PhD doesn't really allow you to build your own life. So any just feel free to take this answer to any context that you want to, but what is one tip that you would say to any person who is genuinely interested in research, be it a graduate student or a PhD student?
Right. So the answer So the advice will be 3, 2, 1. Okay, never mind. So it's about find a good mentor, you know. So you cannot do research by your own. You can find a mentor online. You can find a mentor like, but you need to find a mentor. So to my opinion, I cannot accomplish this without any like guidance or help from either my PI or either or the senior student or even the junior student or all the members in my lab. So you need some group. So if you go to the industry, then find a group. Maybe you get a group to work on one project. If you go to PhD, then the lab is good. And yeah, the reason is you want to expose as much as possible the good problem. You really don't need to care about what's the solution. You need to like understand what is a good problem, like people really care. And then you figure out the solution. Then you don't need a mentor. You just get online, see some related work. And yeah, the first very challenging problem is you need to find a promising direction. So that's what a mentor meant to be. So yeah, my advice is don't do it alone. Like try to find somebody. Like that's one of the advantage in PhD. You have to bond with one person like 4 years or 5 years. So he have to like help you or educate you. So that's a good opportunity. Like, oh yeah, if you don't think, oh, research is boring. Yeah, so that's his job to make it interesting and convince you what's the significance of the problem that we're working on. Then you get motivated because nobody learns some new things like they really know. Like I learned piano when I'm 8. Yeah, if my parents don't tell me there is a piano in the world, how can I come up with my own, you know? How come an 8-year kid like say, hey, dad, I want to play piano. So what, right? So you need a mentor, like introduce you some piano, and then you can work on it, gradually build some interest on it. So nothing is like interest you like from nowhere, you know? You still need some, a lot of a voice and see a lot of YouTube like this channel. It will give you a lot of good views from different perspectives. So
yeah, that's a really great advice. And yeah, I can see that I'll be using that advice personally a lot. I don't know about all the people who are watching this video, but yes, that's really critical. But yeah, this conversation has been great. I don't know if Vatsal has any other questions.
No, I
If
don't have.
Yeah, in that case, I'll just thank Vatsal and Zongwei, both of you, for taking out the time. I'll thank Vatsal because he was the person who got in touch with Zongwei for this particular video, and of course, thanks a lot, Zongwei, for taking out the time. I know I'm really fortunate because by the next year, I guess you would be joining at some university as a professor, and it would be really hard to get in touch with you for this kind of video. But I'll be proud enough to say that, okay, I interviewed Zongwei a year back. So yeah,
hopefully.
but on a serious note, thanks a lot. I really hope this video is really helpful to people who are jumpstarting their career into research on in general, deep learning or any other machine learning domains. So thanks again. Thanks a lot. I'll leave a if you don't mind, I'll leave a LinkedIn profile of yours in the bottom for any people who are genuinely interested in getting in touch with you for any other
Of course, like
doubts.
scan this barcode.
Yeah, like right here.
Yeah, right here, you know.
I think he has
of
his own website, zongweis.com.
Yeah, zongweizhou.com.
Yeah,
Yeah,
I'll also
check this out.
Yeah, I'll also put a link to your profile so that people can get in touch with any ways possible. But yeah, sure. Thanks a lot, and
Thank you.
see you guys around in the campus.
See you. Bye-bye. Bye.
Bye.